All right, welcome back to trigonometry. So we have another problem. This is problem 9C. So here we are. We're looking at what's going on. Hi, babe. Um, we're going to go ahead and factor this thing. And again, we're going to look at first pair, second pair, and see what that does for us. Okay. He is the only cat that I have that likes to be on screen. This is Doogie Meowser, MD, I think. But we'll figure that out. Okay. First pair, second pair. So we have a 4 cosine squared x on my first term here. What's left is going to be 2 cosine x minus 1. Okay. And then for the second problem, we're going to have a minus 9. And then that's all we're going to have out of here. So this is going to be, we have a 2 cosine x, right? Change the signs because we took a sign out. Okay. We pulled out a minus 9. So we're going to say minus 1 here equals 0. All right, so here we go with this. We have a 2 cosine x minus 1. We have a 4 cosine squared x minus 9. Now, this one is a little bit better of a problem because as far as the seeing a difference of two squares, like this is a pretty obvious difference of two squares because 4 and 9 are both perfect squares. So here we have a 2 cosine x minus 1, right? And then here we have a 2 cosine x minus 3, we have a 2 cosine x plus 3. Recognizing this piece here is a difference of squares, we have a squared x squared, a squared x squared minus b squared. We could separate this into ax minus b, ax plus b, and that's kind of what I did here. Okay, so let's go ahead and finish this guy off. So we have 2 cosine x minus 1 is equal to 0. We have 2 cosine x minus 3 equals 0. 2 cosine x plus 3 equals 0. And we're just solving for cosine here. So this one is nice too because we don't have a reciprocal function. So we have cosine of x is equal to 1 half. We have cosine of x is equal to 3 halves. And then we have cosine of x is equal to negative 3 halves. I'm just isolating my cosine x's in each case here. Okay. And just adding 3 divided by 2, subtracting 3 and dividing by 2, etc. Okay. So cosine x equals to 1 half. That one we can say this is x is equal to the inverse cosine of 1 half, which conveniently happens to be 60 degrees. Okay, we can go ahead and plug that into the calculator and see that. Or if you remember, like, oh, that's a unit circle piece, that would also work. It's pi over 3. Okay, since the problem suggests that we answer in the form of degrees and with a decimal, we're going to go with this guy right here. So it's 60 degrees on the spot. You don't have to put the point 0, 0 and like that. We're not going to do that. Now, cosine x equals 3 halves. Again, remember what cosine looks like, right? The graph for cosine looks something like this. The highest points that we have here are 1. 3 halves is bigger than 1. Okay. The smallest point we have here is negative 1. Negative 3 halves is smaller than that. So here's my negative 3 halves. So both of these equations, both of these factors yield a no solution because cosine never reaches these lines. Like cosine will never intersect this line. Cosine will never intersect this bottom line. This can never happen. So we don't have to worry about these solutions because they don't exist. The only thing we do have to remember is where else is cosine positive? Cosine is positive in the fourth quadrant. So we also need quadrant 4. So 360 minus 60 degrees for my quadrant 4 gives me 300 degrees. Or if you remembered your unit angles, unit circle angles, you could also say this is 5 pi over 3. Okay. So we're going to report our answer to be 60 degrees and 300 degrees. Okay, this is equal to S, and we'll go ahead and do it this way. Like, that's a pretty good problem. So it's got a nice little solution to it. I like the way this works out, and then there we go. Okay, so thank you very much for watching the video. Again, don't get intimidated by the factoring. Just realize like it's first pair, second pair, and I got no other tricks up my sleeve other than that. Okay, that's the best I can do for us. So again, thank you for watching the video, and I will see you in the next one. Take care.